Hello everyone, my name is Xiaobai Li, and I just finished taking the EC 470 this semester, which is the Intro to Robotics. I used to think that robotics is a very complex concept, which includes a lot of things, and after taking this course, I know that I'm kind of right, because there's a lot of knowledge in robotics. You need to know the knowledge of probability, you need to know the knowledge of a lot of math, you need to know how to coding, and you need to know about robotics concepts. And I think one of the most important concepts we learn in this semester is this one, which is the forward kinematics. So basically, the forward kinematics is like given the angles of all the joints, which is these kind of things. Given the angle of all the joints, we can get the position we need to reach. And this is extremely important for any kind of robot, because I think for 90% of robots, you definitely need this kind of things to calculate the position. Right? It's very practical, and I think we are using it in a daily life a lot when you are related to some kind of robot. And it's fairly straightforward to solve this kind of problem. And right now I'm going to show you an example on how to solve a forward kinematic problem. So this problem is a very typical problem, which is derive the forward kinematics of a robot with several joints. So right here we can say like we are given two frames. This is frame 0, which is the base frame, and this is the frame 1, which is the robot frame, right? We are trying to find the pose of the frame 1, okay, which is a T right here. And we have two unknown things. The first one is the M, and the second one is the B, alright? So how do we find the M and B's? For M, it's kind of simple, and the formula is given right here. So the M is basically a 4x4 matrix, and it's R, P, 0, 1. So for this formula, the R is a 3x3 matrix. Alright, it's a 3x3. And the P is a 3x1 matrix. Okay? And the R is the rotation of the frame, which is like the rotation of the axis. In our problem, the x1 of the frame 1, the x-axis is the same as before. So right here, for the first column, we need to write 1, 0, 0. So this is x, y, and z, right? So the x-axis remain the same. And for the y-axis, we can see that right now, the y1 is the same as the z-axis before. So this is 0, 0, 1 for y. And similarly, we are using the right-hand rule, which is your finger is pointing towards the x-axis, right? And then curl to the y-axis. Then the thumb you're pointing is the z-axis. So right now, our z-axis should be the negative y-axis before, which is 0, negative 1, 0. Alright? And for the P, it's just simply like the displacement of the new axis. Alright? Which is 604 in this case. So we got our M right here, which is 1006, 00, negative 10, 0104, and 0001. And to find the B, we need to use this formula right here. So B is given by omega and V. So how do we find omega? There are two kinds of joint. The first one is the prismatic, which is not rotating, right? For the prismatic, the formula is given like this. The omega is always 0, 0, 0 for the prismatic joint. And V is given by the direction of the prismatic joint. For example, for this one over here, the direction is pointing at the direction is pointing at negative y direction. So the V should be 0, negative 1, 0. And right now we can find the B for the prismatic joint, which is 0, 0, 0, 0, negative 1, 0. Alright? And the other kind of joint is a rotation joint. Okay, alright. So for the rotation joint, the omega is gonna be the direction is pointing at. Let's say for this joint right here, it's pointing at this direction over here. Alright? Which is the positive x direction. So for omega, it's gonna be 1, 0, 0. For V, it's gonna equal to the negative omega q, where the q is the displacement from the origin, okay? And the formula of the omega is given right here. So we can get the omega is gonna be 0, 0, 0, 0, 0, negative 1, and 0, 1, 0. And a q from the frame 1 is gonna be negative 4, 4, and 0. If you do the product of the matrix, we'll get, oh, there's a minus sign right here. If we do the product of a matrix, we'll get the answer of this one is gonna be 0, 0, and negative 4. So the B for this joint is gonna be 1, 0, 0, 0, 0, negative 4. So right now we know how to calculate the B for prismatic, and we also know how to calculate the B for rotation joint, and we can get all the B for all the joints right here, right? And then we can get B, and we already got M. So in order to get the transformation, we can just plug in all the M and B's, and we'll get a T. I think this is very interesting and it's not too hard to get, and I hope I can learn some more robotic knowledge in the future. Thank you.